So today we're going to talk about rational numbers and then look at the idea of absolute value as we work through this problem. So a rational number is what we're going to first talk about. What are these types of numbers? What are these kinds of things? To give you some vocabulary background, the most specific, the most general is down here on the rational number section. Give myself the right color pen. All right, so a rational number is really any number that can be written as a ratio. So we're looking at both whole numbers or fractions, decimals. No, I don't need an X on that, an N on that. Fix that as a ratio. So examples like 1 can be written as 1 over 1, or 3/4, or negative 0.05. All of those are considered rational numbers, okay? Moving on to the next most specific is the integer number system. It's easier to give you guys kind of a list of what these are. These are all positive and negative whole numbers. So some like from -3, -2, -1, 0, 1, 2, 3. So all positive, I'm gonna put a plus, and negative whole numbers. So no fractions, no decimals. Okay? A whole number, the biggest difference between this is positive numbers including 0. Positive numbers, positive whole numbers, I should say. Numbers including 0. And that's the biggest key on this one. 0 is not positive, but it is also included in this. So, 0, 1, 2, 3, and 4, ... Keep going until you can't run out. And then natural numbers are things that occur in nature. If you think about nature, you really can see that it's numbers 1, 2, 3, 4, ... Another name for these are called counting numbers. Okay, so numbers that you can count to. And when you start counting, you can literally count 1, 2, 3, and as high as you can go. So when I say these terms throughout the class, especially the integers and the rational number system, I want you guys to be able to think about this and have an idea in the back of your head for this. Now, so the idea behind a graphic example is going to kind of look something like this. I'm going to get my drawing tools out. I kind of think of it as a giant cake. So here's this idea of a rational number. Rational numbers are pretty much everything. I'm going to put it right here. Okay? After rational numbers, I'm going to switch colors here. Let's go to a different color. Let's go red. A red circle on this one. A red circle. These are my integers. Not all rational numbers are integers, but a good chunk of them are. So we're saying these are integers. Then after integers, we've got whole numbers, and a good amount of the integers are also whole numbers. So make this a little bit bigger. There we go. I'll line everything up here in the middle. So we have this idea right here. These are our whole numbers. This includes 0. And then finally, pretty much every single whole number is also a natural number. We'll make those dark blue. Okay, these are my natural numbers. Natural numbers, pretty much the only number that's a whole number that's not natural is going to be 0. So this kind of looks like a cake. If you think about this a little bit, it kind of looks like a wedding, like a 4-tiered wedding cake, with rational being the biggest, followed by integers, which doesn't include decimals and fractions, but has all positive and negative numbers, up to a little more specific whole numbers, 0 and bigger, all positive whole numbers, and then finally natural numbers, which start at 1 and go up to infinity, as long as they're all whole numbers. Okay, so one of the things you can do with this is thinking about this number system. We have to think about ordering numbers from least to greatest. So if we're thinking about this, really it's a development of the idea. It is not the lower the number that gives you the less. It is the farthest to the left. So to the left is the smallest. Left is spelled with a T, and F is less. So if I'm going to say these right here, this one is -9, is much lower. -7, -6, -3. A way to think of a lot of this is kind of make it money. Would you rather owe $9 or owe $3? Obviously, you'd rather only owe $3 because you owe less money. And then, but when we're talking about over here, we have the complete opposite. The farthest to the right is greater. So when you're above 0, and this is actually true here, -3 is actually greater than negative 9. Even though the digit value is greater, it's farther to the right on the absolute value. Okay, so we kind of get an idea of how these work. If we take a look at these, if I asked you to graph these, you would take out your number line is the easiest way to graph something like this. And you pull a number line out. I always start by putting 0 in the middle. There's my first one graphed. 1/2, 1, negative 1/2. So all this negative stands for is left of 0. So there's my negative 1/2. There's my 0. There's my positive 1/2. And then there's my 1. Okay? And I do the same thing down here with these numbers. Okay? So if I've got 0 here, we've got 1.5 here, and negative 1.5 over here. So the idea that farther left, negative just means left of 0. All right, now taking a look at absolute value. This idea is something not new, but it's a different idea. So I like to make this think in terms of that same number line. So if we take that same number line we just drew, and I'm going to make it even easier, 0, negative 5, and 5. 1, 2, 4. Okay? If you're talking about absolute value, you're really talking about the distance from 0. So the idea is, regardless of positive or negative, how far are you from 0? The absolute value is just simply here. It's 5. And you'd write it as these absolute value symbols. That's how you find absolute value of 5. Where the absolute value of 5 is still 5. They're both the same. Because if you look at them, they're absolutely the same distance from 0. It has nothing to do if it's left or right, it's just how far. Okay? One of the things about distance, if you think about this, you can't go less than 0 feet. If you walk to a negative 5, you can't do that. You can't move less than 0. The lowest you can ever move is 0. So you have to move to the left 5 or to the right 5, but still 5 steps one way or the other. Okay, so if I'm finding the absolute value of a number, how far is 125 from 0? What's 125? How far is negative 0.25? Well, it's 0.25. And how far is negative 5/8? Well, it's 5/8. Take a second, pause the video, and see what you come up with for D and E. Now, these are different. The negative sign is on the outside, so it's not going to be affected by the absolute value. So this one happens to be negative 8 and negative 2.7. Because that negative is outside the absolute value, it doesn't get affected by the absolute value signs. So if we follow a problem like this, the whole idea of an expression is just being able to plug things in. What am I going to do first? And this is where I want to bring into the idea of GEMDIS. An absolute value symbol is one of the grouping symbols. We're used to parentheses, brackets, braces, or braces, brackets, and finally the last one are the absolute value symbols. So the first thing you're going to do, you're going to treat this just like a set of parentheses. 12 minus 8 is 4. 4 plus 5, the answer is 9. All right, if I plug in 5 to this one, go ahead and find the answer for me. You're right, it would be 3 minus 2, which the answer is 1. All right, so that gives you all the basics of absolute value. It's a pretty good set. The key to remembering absolute value is how far a number is from 0. Okay? If you have questions, feel free to reach out to me, and I'll happily help you walk through any of the problems.